I won't need the calculator for this. That'll work perfect. All right, so where were we? Still doing this one. This doesn't work. So right here, it's like, oh, I can pull the 3 out. So it's 3, and then I'm going to change that to 1 over sine squared of x dx. Right? Well, 1 over sine squared of x, you know that, don't you? The excuse me, you don't know that. It's the same as cosecant squared of x.
Why?
Because that's what it is. Is it 1 over sine cosecant?
Like
1 over cosine secant. Remember those? And so now I can figure out the antiderivative. What's the antiderivative of cosecant squared? Well, if you need to. Remember our little derivative chart? Secant, secant, tangent. And then underneath them you put the opposites. Opposite of secant's cosecant, cosecant, cotangent. But this one has a negative. And so what's the antiderivative of cosecant squared?
Negative cotangent.
It's cotangent. The derivative of cotangent is negative cosecant squared. So if I just do negative cotangent, so negative 3, the 3 is still there, cotangent of x plus c. That's it. No u substitution involved. That if you're doing the u substitution, I never did. I never used u. I didn't need to. I changed it to cosecant squared, and I know the antiderivative of cosecant squared, so I didn't have to use a u. That's going to be the challenging part now, because for this homework, it told you use u substitution. Well, in the future, it'll just be like, do the integral, and you have to figure out what you need to do to be able to do it. And okay, we're doing some more today. Yay. More u substitution. Now, though, they're going to be definite integrals. These are indefinite integrals. They're not defined. There's no.
Didn't we do definite ones?
We did definite, but simple ones.
We did simple ones. You didn't have to use u substitution.
Then we gotta find a definite interval.
And this, I think you'll like. It's pretty straightforward and easy.
What we're doing, but gotta do it.
Well, I'm not saying, I don't know if you'll like it.
You just said it.
Oh, you'll love it, Riley.
What?
Just going to do an example here, show you how it's done. We'll do 2. You're famous now. This is going to have like 3 views by the end.
Awesome. No,
So-
probably 2 at the most, because Mike and Zach are the only ones.
That's true.
So one of us watches it. For fun. Because there's nothing better to do this whole weekend.
Well, good, because I got quite a list of stuff for you.
No, we do. We have 2 games. And
So there's what we're trying to do. From 0 to 1 of t to the 5th plus 2t, square root of that, plus 5t to the 4th plus 2 dt. That does look fun. This one's actually not bad.
Hey, look, I can find an
the
answer for that.
5T will go away.
I can find an answer for that.
Okay.
It's number 59.
Yeah. It's not really.
I just picked a couple of the numbers. All right, so what do you think we need to do? You know the first.
Are we using u substitution?
Do you think you need to? Do you know the antiderivative of that ugliness?
VT to the 5th plus 2t?
Oh, u.
Yeah, you would.
Yeah, we'll let u equal t to the 5th plus 2t.
Why couldn't it be 5t
Square
or 4
u.
plus 2?
du.
Because it'll go
It could be, but then think about du, and that'll equal 20t to the 3rd, and then you're going to divide this by 20t to the 3rd, and nothing's going to go away. And
Or you could just do that part and then factor the thing.
So now we got, I'm going to leave the numbers off of here for right now. You'll see why. So we'll have square root of u times 5t to the fourth plus 2 dt. Well, okay, so that's u, so du is 5t to the fourth plus 2 d. That's convenient
Hey. Yeah, that's cool.
because now dt equals 1 over 5t to the
So those
fourth
cancel.
plus 2 du. So yeah, when I plug in for dt, I'll have, and I'll show all the work here, square root of u times 5t to the fourth plus 2. Well, dt now is 1 over 5t to the fourth plus 2 du. And yeah, those are going to cancel. So now I have square root of u du. But hold on, this is where it changes. Yeah, the numbers. These numbers were from 0 to 1 for t, for this function. Sorry. I want you to write this down before I speak. Oops.
Okay, go on.
This was for 0 to 1 for t, right? But we changed it to u, so we need to also change these numbers. So all we have to do is do, for 0, what is u of 0? Well, if I plug in 0 for u, 0 plus 0 is 0. What is u of 1?
3.
2.
1
3.
plus 2 is 3. So now I'm going from 0 to 3 of square root of u du.
Oh, that's awesome.
So now, change that to u to the 1/2. Now we got this. Well, now we just do the integral with u. So antiderivative of u to the 1/2 is that u to the 3/2, 2/3 u to the 3/2, and then just do that from 0 to 3. You never have to go back and plug that in.
Oh, that's cool.
So now you'll just do 2/3 times 3 to the 3/2 minus 2/3 times 0 to the 3/2.
I think I do like that better.
So,
This is 0, so it's the final answer is 2/3. It's just that.
so if you didn't change the numbers, you'd have to plug it back in.
Yeah,
It'd still work.
it still work. It should work still. Yeah, I never even thought of doing that. Yeah, you could take the 2/3 u to the 3/2 and do 2/3 times t. Plug this back in for u and then use your original numbers. It's just more work. Huh? You want to see another one? A little harder.
These problems like take up half the paper.
Yeah, literally.
Show you one more here.
That's why we don't get a page of problems.
0 to pi over 6 of cosine of a -3rd 2 theta sine of 2 theta d theta. Pure ugliness, I tell you, right there.
That is like all the words I never received.
Pi, theta, cosine, negative
Yeah.
3.
What do you think you should equal?
Cosine of negative.
Did it?
Sine 2 theta.
Sine of 2 theta? That's what I thought at first, too. I'll tell you right now, it doesn't work. Just for the sake of time, it doesn't work.
Cos?
Two theta.
Or should
Um,
we just do that?
And actually, here's what I did. This one took a lot of thinking. I didn't write a lot down. Try u equal to sine of 2 theta du would equal cos of 2 theta d theta, and you end up with just more mumbo jumbo, and it doesn't work. Theta doesn't go away. Doesn't work. So I changed this to, I'm going to leave the numbers off, sine of 2 theta over cosine to the negative third of 2 theta
Negative
d theta. Oop, positive. And then I went further. I changed it more. So I was like, well, this is the same thing. Well, this is the same as sine of 2 theta over cosine of 2 theta times 1 over the cos squared of 2 theta. Right?
Oh, that makes sense.
And this is tangent of theta.
See, I would never be able to do this by myself.
Time 1 over cos squared of 2 theta. And there was a lot of I didn't just like try this. I was like thinking way ahead.
Then you have tangent.
Like kind of just doing it in your head. Before you, because then I was like, okay, let's let u equal the tangent of theta. So du will equal the secant squared of theta, d theta. Which means d theta equals 1 over secant squared theta du. What? Did you say the question?
Yeah. Where it says times 1 over cosine squared of 2 theta.
This, I said, you know, I had cosine to the third on bottom here.
Mm-hmm.
I just separate it. Sine over cosine times 1 over cos squared. Because if I multiplied these back together,
Oh, yeah.
it'd be sine over cosine to the third, right? Is everyone up to speed here? U is tangent, du is secant squared, which means 1 over secant squared is times du.
Would it be tan of theta or tan of 2 theta? Why do the 2's cancel with the theta still?
Where are we talk? Oh, yeah, 2. That should be a 2. Good, I missed that.
And then 1 over cos squared.
And that's a
is
2.
secant squared.
Which means this is 2 secant squared of 2 theta. I missed all the 2's. Which means it's 1 over 2 secant squared of 2 theta du is equal to d theta.
Secant squared. Go away.
1 over cos squared is secant squared.
Yeah, so secant.
So yeah, no, it's nothing's gonna go. It's not actually gonna go away. U is tangent to 2 theta, so I'll have u there times 1 over cos squared of 2 theta. D theta is all this, so times 1 over. Oh yeah, it is. You're right, Rumbles, as usual. 2 secant squared of 2 theta.
Then you do just realize that secant squared is cos squared.
Yeah, what is 1 over cos
Or
squared of
that,
2 theta?
Either way.
This is secant squared of 2 theta. So look what happens. Secant squareds go away, and you're left with.
1/2 u du.
Why did I get this wrong?
Is that wrong?
Yeah. You forgot something. I did it earlier. That's not the same thing I got.
Maybe you're wrong.
Did you do it wrong earlier?
You need to stop listening. No, I know I didn't do it wrong earlier. I did it a little different earlier. Maybe it's not. I don't know. We'll see. Let's just keep going here. Maybe it's going to turn out okay.
Then you do your,
I just did it. I did it a little differently, so maybe it's going to be all right. So now we just do this. Oh, wait, we need our new numbers.
yeah.
We had pi 0 to pi over 6. So we need to do u of 0.
This,
So that's the tangent of 2 times 0. So the tangent of 0, which if you don't remember your unit circle,
What?
no, it's actually the square root of, it's 0.
I was like, is it just zero?
Square is zero.
Yeah, because sine of 0 is over cos of 0, so it'll be 0 over 1, 0. So we're going from 0 to u of pi over 6. It's the tangent of 2 times pi over 6, so the tangent of 2 pi over 6, which is the tangent of pi over 3, that's the square root of 3. We'll just save time and get that over with. Square root of 3. So if we're going from 0 to square root of 3 of this, now it's easy. Antiderivative of that is what?
1/4 u squared.
1/4 u squared.
Yeah, because you have half of it.
0 to square root of 3. Square root of 3 squared is 3. 4. Yeah, this is wrong.
Gosh.
Gosh! I know, I'm frustrated too.
I just use like a.
It just
whole
seems
half
to work
page.
out so nicely though. At the end, yeah.
The answer I got earlier is 3 over 2. We got 3 over 4. So that 1/2, unless I messed up earlier, I checked the answer supposedly, and this feels right though.
Okay.
Yeah, well, most of our answers feel right, and then we're wrong. So.
Life's tough.
In this class.
Oh, well. I'll figure out the issue here, and you get the idea though with how to do the definite ones. The only difference now is doing the u of those to get your new numbers.
Okay,
And the u.
just to be clear. So you still do the same
It both
steps,
says it's 2, we're at 3.
and then at the end, when you
This is number 60. You don't have this one.
Huh?
This is number 60.
Rachel. Okay, come here.
No.
You have to
Oh,
go
yeah.
inside. You have to take right by Rachel.
Okay, yeah,
Hurry,
but still.
There, hard, right there.
Yeah, 2 or 3. That was the last one we just
Yeah.
did. What?
um,
You do all the same steps.
you do all the same steps, except you don't do the antiderivative, right? You don't do that. And
Yeah, you do. We still did that.
Okay, yeah, but that's after you do. Okay, you do all the same steps, and then when you get to that one part, that last part, before you do the anti, you need to get your other u's. So you plug in
You need to get your new
your
bounds
new, your
for
new
your
numbers
integral.
for your integral. Okay, so you do that by plugging in those numbers
To you.
okay, to you. You do that, so you
This is
do
two
that.
problems,
And
guys.
then,
I know.
that's where I'm lost.
Now we do the antiderivative, which is that.
You put those numbers onto the number line, 0 to
Sometimes.
square root 3, and then you do the
And then you plug that in, right? Square root of 3 squared is 3 over 4.
Hopkins, can I tell you something?
Let me shut this camera off first. So,
Is it off?
nope. I'm gonna write the homework down real quick. 7.2, 38 to 44, 47, 48, 53 to 56, 58. Lots of fun to be had there.
Well, don't come to school Monday then. You can work on this.
Okay, thanks. I'll stay home.
It's
Bradley?
being filmed as well.
Bradley told me to stay home. No, it's still on. Now I'm shutting it off. Right.